Alright, welcome to the video for lesson 14 on even and odd functions. So in class we learned about even and odd functions. We learned that there were some things that help us identify which one is which. One of them being if it's an even function, it has line symmetry with regards to the y-axis. If it's an odd function, it has point symmetry or rotational symmetry of 180 degrees about the center. So there were other things we could do algebraically, but we'll talk about that later because the first question is just about graphing. So question 1 gives us this funny looking function and it asks us to find the other half of it if it's an even function. So if this is an even function, I know any point on the y-axis is going to stay on the y-axis. This point of 3, -1 is going to become -3, -1 because I'm just reflecting it over the y-axis using all those fun geometry rules you learned last year. The next point on my graph is 1, 2, 3, 4, 5, 3, so it's going to become -5, +3, and I could even start connecting some lines. And the last point is 7, 2, so it's going to become -7, 2, and I'll finish the graph off to look like that. So essentially, if I was to fold my paper along the y-axis, my blue graph would be right on top of that black graph. So for the odd function, it's rotations of 180 degrees. So to rotate something 180 degrees, you just negate both the x and the y value. So 0, 0 is not going to change. That's actually right at the center of rotation. 3, -3 is going to become -3, +3. The next point on this function is 5, 5. So it's going to become -5, -5. You can even start graphing. And the last point is 8, 3, so that's going to become -8, -3, and we would finish the graph to look something like this. Now for this graph, we would be able to say if I was to rotate this black graph 180 degrees, or essentially flip it upside down, where would it be? It would be over here where that blue graph is. Let's look at 2. 2 says to determine whether or not this function is even, odd, or neither. To do that, I'm going to plug in -x. So I have 3 times -x to the 4th power minus 7 times -x squared plus 5. So one of the things that we learned in class was that if f of x is equal to f of -x, it's even. If -f of x is equal to f of -x, this function is odd. So essentially what I'm trying to figure out now is if I evaluate this with the negatives in there instead of positives, what does my function look like? So I can say f of -x equals 3. If I take a negative and raise it to the 4th power, it's positive. If I take a negative and raise it to the 2nd power, it's positive. So this function remained the same by plugging in a negative value. Because it remained the same, I know this function is even. So this is an even function.
Did you fill out a form?
Alright, sorry about that interruption. So for number 3, it says describe each function as either even, odd, or neither. So for h of x, we're going to be able to say that h of x is an even function. Because it has line symmetry with the y-axis. Right, I see point here becomes this point here. Any point on this graph is just reflected over the y-axis. For this next one, we didn't give it a name, right? So let's just give it a name like f of x. Right? So we'll say f of x is neither because it has no symmetry. Right? This would be an odd function if it passed through 0, 0. It doesn't. So this point 0, 1, if I reflect that, it becomes well, it just becomes 0, -1, so that would be down here. So if I was to do that 180 rotation, it would be in a different location than where this graph is, so it doesn't make sense. Okay? I hope this video helps. Keep in mind that we are going to have a quiz pretty soon, since we've done a few more lessons than we were probably expecting before our last quiz. Have a good night.